Thanks for tuning in today. My name is Jamie Ratchford. I work for the California Department of Fish and Wildlife as a vegetation ecologist. And today I'm going to be talking about using fine-scale vegetation maps to examine habitat level relationships between passerines and vegetation in the Modoc Plateau. So a little bit of background first. The Vegetation Classification and Mapping Program or VegCamp as we call ourselves, is a program within the Department of Fish and Wildlife. And we develop and maintain California's vegetation classification system. Or in other words, we define and describe all of the natural vegetation types found in California. Our classification system considers not only the dominant species in stand, but also associated species as well, which allows us to provide more information about the variation we find in vegetation. The California Vegetation Classification can be found in a Manual of California Vegetation, which is now an online tool and is updated regularly. Along with classification, we also produce fine-scale vegetation maps. These maps are developed using on-the-ground data, our floristic classification that we develop from the data, and we use that to digitize polygons using GIS. Every polygon is given a vegetation name, usually at the alliance level. And they also have a suite of attributes, including cover of different strata, heights of strata, and also things like invasive species cover or other disturbances that might be present in the region. All of our maps go through a rigorous accuracy assessment and must meet 80% accuracy level. We currently have a little more than half of the state mapped, with the goal, of course, to map the entire state. And these maps are archived and available on CDFW's BIOS website. Vegetation is an excellent surrogate for habitat and ecosystems, and our vegetation maps can be used in a lot of different ways, including regional conservation planning, fire and fuels planning, identifying wildlife corridors, and setting baselines for monitoring projects. Today, I want to highlight how fine-scale vegetation maps can be used to improve habitat modeling. Ecologists often examine and model the relationship between wildlife and plant communities. However, these habitat models have their limitations. They often provide easy to interpret variables, but can be difficult to translate into spatially explicit information at a landscape level. We conducted this study to examine how these relationships can be extrapolated across a large geographic area using our fine-scale vegetation maps. And we also wanted to compare how our vegetation classification performed in these models as compared to CWHR habitat classification. And CWHR is the California Wildlife Habitat Relationships, and that's often what is used by ecologists in modeling. So for this research, we focused on an area of the Modoc Plateau. This is an area of California with very low human population. However, it is strongly affected by human-caused disturbances and is experiencing rapid changes in vegetation patterns. The ecosystems here, like many other places in the Great Basin, have been considered among the most threatened in North America. In 2016, VegCamp, along with collaborators, began collecting vegetation data for the region to produce a classification, and we now have over 1 million acres of vegetation map at a fine scale level. Also, the California State Wildlife Action Plan has identified 7 species of concern for the Modoc Cascades ecological province. And these are the green-tailed towhee, the sagebrush sparrow, brewer's sparrow, gray flycatcher, western meadowlark, loggerhead shrike, and the lark sparrow. So with having the vegetation map completed, we had the vegetation information that we needed, but we needed to survey the breeding bird presence in the region. So we used a stratified random sampling to allocate map polygons across the mapped area. And we were representing 15 of the vegetation types found in the region. There's many more vegetation types in the region, but these 15 represented 90% of the vegetation types mapped in the project area. At each site, we placed an automated recorder. These recording stations recorded bird vocalizations 3 times a day, before sunrise, at sunrise, and after sunrise. And we did it for, left them out to record for 3 consecutive days. These surveys were conducted across 2 years, so some sites were surveyed in 2018 and some were surveyed in 2019. All the recordings were then interpreted by an ecologist at UC Davis. So after 2 years of surveys, we had obtained over 300 bird surveys. Each of the 15 vegetation types that we were targeting had at least 11 bird surveys for that vegetation type. And all 7 of our species of concern were sampled adequately to develop occupancy models. And overall, we had data to model 88 bird taxa. To develop our occupancy models, we summarized the landscape composition within a 250-meter radius around the recording station. The landscape composition was calculated as the percent cover of each vegetation type present. And we also looked at exotic plant cover, and we accounted for the temporal variation of the surveys, whether it was recording time during the day or the year of the survey. So we found some interesting general trends between bird species and vegetation. We detected the greatest number of significant relationships with the forest and woodland types. And this included western juniper, or Juniperus occidentalis, also quaking aspen stands, Populus tremuloides, and also the California montane conifer forest and woodland group. And these are alliances that are usually dominated by species like white fir or Jeffrey pine or ponderosa pine. We also found numerous species that were strongly associated with 2 shrub types, one of them being Artemisia tridentata vasiana, or mountain big sagebrush, and the other one, mountain mahogany, or Cercocarpus ledifolius. So we wanted to compare how our vegetation classification system compared with the CWHR. CWHR, again, that's the California Wildlife Habitat Relationships. Their habitat classification is broader than the MCV, or the California Vegetation Classification. A good example of this, which is a very important type in this region, is the sagebrush. CWHR has a sagebrush type, and 5 of the MCV, or California alliances, are lumped into this CWHR type sagebrush. However, they're not all ecologically similar. For example, Artemisia cana, or silver sagebrush, is a wetland type vegetation, and it's more related to wetland vegetation than it is to the upland sage alliances. And there's also species of birds who are positively correlated with this vegetation type, including the red-winged blackbird. So we assessed the models using the California, the MCV classification, and also the CWHR. And we found that the MCV classification models received more support than the CWHR did. So here's a chart showing the positive and negative relationships between bird species and the different sagebrush types. The CWHR is on the top, of the red line, and this is the conglomerate. And then the 5 alliances that are found in the MCB are below. And one thing to note here is that no bird species that was positively correlated with the CWHR type was positively correlated with all 5 of the state alliances. And this is true for 3 of our species of concern, the brewer sparrow, the green-tailed towhee, and the sagebrush sparrow. We also see situations like in this example, these 2 examples, where species are even found to be negatively associated with one of the alliances that's found in the CWHR type, even though it was positively correlated with the CWHR sagebrush. So we found the best fitting models using the MCV classification. And then we wanted to interpret these variables into spatially explicit information at a landscape level. We used a moving window analysis to map the landscape composition across the study area. And we used the coefficient estimates from the models to map predicted occupancy for each of the 88 bird taxa that we modeled. And we also did this as a composite map for predicted species richness. So here is the resulting heat map of the predicted species richness, with the red showing highest species richness and blue showing lowest species richness. We found a couple of general trends is that species richness was highest in areas with higher proportion of low sagebrush, and species richness generally declined with an increasing prevalence of exotic plant species. So we're also able to look at species individually and or compare them with other species. And here's a map showing examples for the 3 species that we saw earlier, the green-tailed towhee, the brewer sparrow, and the sagebrush sparrow. Remember, these were all 3 positively correlated with the CWHR sagebrush type, but they had some differences at the alliance level. We can see here that the green-tailed towhee and the brewer sparrow in red and blue are strongly associated with habitat found in the northern portion of the study area, whereas the sagebrush sparrow was associated with lower elevation, drier vegetation of alkali flats that are found mostly in the southern portion of the study area. So we feel these findings highlight the subtle differences in habitat associations of shrubland bird species, and it underscores the value of a detailed vegetation classification and mapping, particularly for purposes of predictive species distribution modeling. So if you're interested in learning more about California's vegetation classification or the products that VegCamp produces or our mapping, please visit our website, our CVFW website listed here, or feel free to contact any of us in the program. Thank you.